Hello friends, welcome to my channel. Let's have a look at problem 2398, maximum number of robots within budget. So in this video, we're going to share a solution based on the standard two-pointer sliding window technique. First, we'll look at the problem statement to digest the requirement, and then we do a simple analysis, and finally we share the code. First, let's look at the statement. So we have n robots. So we are given two zero-indexed integer arrays, one called chargeTime and the other called running costs, both of length n. So the ith robots costs this amount of units to charge and costs this amount of units to run. So we are also given an integer called budget. So the second paragraph defines what's the total cost for a consecutive selected robots. So it's the maximum of the charge times plus k times the sum of the running costs. So here k is the length. So we are required to return the maximum number of consecutive robots we can run such that the total cost does not exceed budget. So that's the main body of the statement. So here are two examples. So example 2 actually is very special. So in this example, so we cannot choose any of the single robots. So because the budget is small. So in this case, the output is 0. So in example 1, so the output is 3. So we can choose at most 3 consecutive robots to run. So so this is the explanation. So if we choose the first 3 robots, so the maximum time is 6 charge time, and the sum of running cost is 6. Then 6 plus 3 times 6. Here 3 is the total number of consecutive robots. So we get 24, which is less than 25. So if you check other cases, so we can result in getting a 3. So these are the two examples. So before we look at the analysis, so let's look at the constraints. So the first constraint said that the two arrays are of the same length, and the second item defines the problem size, which says that the length of the two arrays can be up to 5 times 10 to the power 4. And the third one basically specifies the range of elements in the two arrays. And the last one specifies the range of the budget. So with that said, so we are ready to look at the method. So as we mentioned, so we are going to use the standard two-pointer sliding window technique. So the idea is straightforward. So for each index j, so we interpret it as the right pointer. So we want to locate its corresponding leftmost index I, such that the condition in this problem statement holds true. So in this case, we have a length j minus I plus 1 consecutive robots. So then in the process, we just need to do linear traversal and then update the result or the length. So the procedure works due to the following fact. So if we have two right pointers, say G2, which is larger than G1, in other words, in the next or next rounds, so then we have the corresponding left pointer I2 is larger than or equal to I1. In other words, at least I1. So this monotonicity ensures that we do not need to start over again when we look at next right pointer. So let's also emphasize the key point for this problem. So here, finding a running sum is straightforward during linear traversal. However, here we also need to track the maximum charge time in a valid window. So for this, actually we have a lot of choices. So we could use sorted container, or we can use monotonic stack. So in this presentation, we will use sorted list. Let's call it array. So once we use this sorted container, so this will ensure that the largest element is always at the tail, or if we can call it head, based on different convention. So it's always array -1. So here are two walkthroughs for the two examples given in the problem. So for example, in the first example, the return is 3. So for the right pointer is 2, and the left pointer is 0. So this window gives us the largest consecutive robots we can run. So starting from index 0 to index 2, the length is 3, and the total cost is 24. So that's why we return 3. In the second example, so we can choose nothing. So in this case, the right pointers for 0, 1, 2, and the left pointers is resulted larger by 1 than the right pointer. So the total cost is 0. So it's important to notice this point if we cannot choose any of the robots. So with that said, we are ready to share the code. First, let's make some preparations. So I'll split the code into two parts. So first part is preparation. For this preparation, I'm going to get the information about the length. So it can be charge times. So the two arrays, charge times and running costs, have the same length by problem assumption. So we're going to initialize a left pointer I equals 0, and the running cost will set it to be 0 at the very beginning. The array is a sorted list, which is going to be used to retrieve the largest charge time in the valid window. So also we want to initialize a result which is going to find the largest length of a subarray corresponding to consecutive robots. So this is the first part. The second part basically is sliding window and logic check. So for this, we're going to use a for loop here. So actually we can use while loop also. So for j in range n, so j is the right pointer. So we want to push the left pointer as left as possible actually. So for when we look at the current index j, so we are going to increment the cost by running costs j, and also we are going to add the current charge time, the charge times and j to the array. So this way, the array -1 always maintain the largest charge time. So then what we're going to do is that we're going to check the condition. So while array, so in other words, the array is not empty, so that we can continue to check the condition specified by the problem statement. So this is the largest charge time, then plus the length, that is j minus I plus 1, so times the costs. So this is the cost in the window. So if this condition is greater than the budget, so we need to move some robots from the very beginning. So in other words, we want to push I to the right. So in this case, we're going to minus cost, so by running costs I. So, and also we're going to discard or remove charge times I. So this actually corresponds to move I to the next position, to the right position by 1. So we are going to do this. So this is the main logic. So after we exit this while loop, there are two possibilities. So either array is empty or this condition is validated. In other words, the requirement in the problem statement is satisfied. So in both of the cases, we can do this. Result equals the maximum of the previous result state and the possible length, that is j, possible largest length, that is j minus I plus 1. Notice that so this can be 0, for example, in this case, but it's still true overall because the logic is no problem. And then after that, so we just need to return the result. So this actually forms a format of solution to this problem. So let's do a special case check first. Yeah, it passes the first example. So now let's look at the generic case. Yeah, it passes all the generic cases. So I guess that's about it for this solution to the problem. So here we used the standard 2-pointer sliding window method, and the point here is that so we need to use some trick to effectively retrieve the maximal charge time in a valid window. So here in this video we used sorted container. So in a follow-up video, we're going to solve this problem using 2-pointer sliding window method, but with the help of monotonic stack. So actually, if we compare the condition here, this is actually very unlike the monotonic stack check condition. So with that said, I guess that's about it for this video. Thank you very much.